Hey, this is Wes, W3KW. Welcome to the shack, and thanks for stopping by to get your radio fix. On the bench today is a Hallicrafters HA-5 VFO, variable frequency oscillator. This one's in terrific cosmetic condition, and we're going to do a complete electrical restoration. I don't think I'm going to do much cosmetically, as this is a really fine example, and it's fine for vintage cases to show a little life in them, which this one does, but very little. It's really in terrific shape. Let's flip it around and show you the backside. So here's the backside of the HA-5. This cord will be going. There's a 6 and 2 meter output and 80 to 10 meter output. There's key screw terminals for keying the VFO. There's a ground lug, which I will replace. There's a cord, which is going to go. That's going to get a grounded power cord, and a proper fuse rather will be right here, and that's what I've done in the past. I've also got the main filter capacitor. That's by Hayseed Hamfest. Here's the donor cord. We're going to be able to use this connector I built up. You can see this built in other videos, and if you don't want to use that type of connector, you can plug this RCA in. I'm not going to replace the RCAs. They're in perfect condition, and I don't want to drill holes or anything and to remove these rivets. But you can plug this in if you want to use a BNC connector. So no problem there. I know that there are safety capacitors in this thing. I've got replacements there. Here's our fuse holder. And here's the dummy load for calibration. And once we're all complete, we'll go through a calibration using the manual. And then we'll put it on the air using my Hallicrafters T0. Sorry, I've got night on the brain. I've been restoring a bunch of night stuff. My Hallicrafters HT-40 will use that transmitter to put this on the air, and so that should be fun. If that sounds like a good time, stick around, follow along, and smash the like button, comment, and without further ado, I think I'll get this restoration going. Shouldn't take long at all. So when I'm doing restorations, I have a music stand with an LED light. It's a really convenient way to hold the manual so that it's readable, accessible, and doesn't take up any space on the bench. These lights are very inexpensive, rechargeable with USB-C, so it ends up being a nice addition to the workbench area when doing a restoration. All right, I've already cut the power cord off, something I usually do immediately with one of these restorations anyway, so I'm not tempted to plug it in, but this one was in really good shape, and I used the Variac to bring it up, and I think I have a video out on that, and you can check that out. Anyway, we'll pop these 4 screws out and carefully extract the VFO from the case here. Okay, well, that's in good shape. Still has the original sticker on the inside there. Hallicrafters US patent model HA-5 heterodyne VFO. 125 volts, so that's good. You don't really need to run it on a Variac to limit the voltage. It's good to full line current. 50 to 60 cycles. That's neat. That's in great shape. The feet are in good shape too. I usually drill those rivets out and replace the feet, but those are fine. I think I'll keep those. Yeah, this might be one of those rare ones where I don't paint the case. I bet it'll clean up nicely with some Rejuvenate. Let's take a look at what we're up against here. All right. All the crystals are here. That's fantastic. I forget what that 4th one is for. That one is the 2-meter crystal. I really don't care about that. I'm certainly not going to be operating on 2 meters. I probably won't operate on 6 either, but we have the crystal for it. So the first crystal here is the 80-meter crystal, then the 40 through 10-meter crystal, then the 6-meter crystal, and the 2-meter crystal, which is not there. And looks like we're okay here. And all the tubes are in there. I already knew that because I did operate this. And if you've never spun the dial on one of these things, it just feels like it's weighted and loaded. It is so smooth and beautiful. It just operates so well. There's no kickback. I mean, it's just a joy to operate, and this is really a Cadillac of a VFO. And there's even a bottom cover that comes off with one screw, just further isolates any noise from getting in there, and protects all the components on the bottom there. But just a first-class build and design. Here's the capacitor we're going to replace using the hayseed replacement. Let's take a peek at this. God, they do such a nice job. Isn't that beautiful? Look at that. Such a terrific job. Fits right in there, no problem. And then, well, we'll probably replace this bulb just so it has a fresh start, and it'll have years of good service. Otherwise, not too much to do on this side. We'll clean it up, of course, and maybe we'll throw the tubes on the Hickok 539C tube tester and see how they work. This is the rectifier tube here, and it's in good shape. Or the regulator, rather, the OA2 regulator. Anyway, so let me pull the bottom cover off here. Let's see what we're up against under there. I think I need a little bit smaller form factor screwdriver. All right, look at that. Look at these beautiful quality capacitors. I will have to buzz out these resistors to make sure that they're okay, but I'm sure all the ceramics are fine. And these brown drops, I'm certain they're going to be fine. It's pretty easy and accessible to replace the capacitor there on top. But I don't see anything discolored, no damage, doesn't look like anyone's been in here. If you notice, there is a fuse here. See this? Which is, I'm not sure that's original, to be honest with you. But we're going to replace that with a fuse on the back. There's room for it right here. And these are the safety capacitors that aren't safety capacitors. Look at the size of those things. Actually, I might be able to correct myself. 150 volts AC, 1400 volts DC. I'll do a little more research into those, but they're going to get replaced with the new safety capacitors anyway. But all right, well, good. I think we're in good shape to get started. I will start cleaning it up and get this capacitor out of here. There's no waxies in these, so it's a pretty quick deal. Drill a hole here, get this hole opened up just a little bit for new strain relief for the new power cord, and that's about it. Shouldn't take long at all. Oh boy, check this out. I was pulling the tubes to clean them, and look what I found. Hallicrafters. That is so cool. I love when vintage gear has logo tubes still in them. Fantastic. Okay, the restoration is essentially complete. Here's the original capacitor can from the HA-5, and I have the probes on the 100 microfarad section in the can. You can see it's only measuring out at 24 microfarad, pretty low. Not super high ESR for an electrolytic, but it is higher than its replacement. And then the other side is pretty close to where it should be. 24, it's supposed to be 20. ESR is okay, I guess. Again, the replacement does have a lower ESR. So on the back, you can see the new 3-wire grounded power cord, the new ground lug, the new added fuse, and I did change the wiring a little bit. There's the new filter capacitors in there, and you can see the new Hayseed Hamfest capacitor on the top side there. These are the safety capacitors that weren't safety capacitors. They're really just filters. They're filters here as well, but they could fail in a shorted fashion, which could be catastrophic for the unit. This manual is from my friend Pete at Manual Man, really terrific guy and makes first-class manuals. However, I had to add this errata sheet, which removes a 68 picofarad capacitor and adds a fuse. Now, the person who modified this one actually put the fuse in, but he didn't put in a 3/8 ampere fuse. He put in a 3 amp fuse. I put in a half amp fuse, which is pretty close. And if there are any issues, which I doubt, I can alter the size as needed since it's in a fuse holder. And then this capacitor that's mentioned there is this 68 picofarad capacitor right here. Notice there's no part number there. It's removed per the errata, and none of my HA-5s, I have 3 of them, none of them have that capacitor in there. So real quick, here's what I did with the AC section, if I can focus in on that. Okay, here's what I did. The hot comes in, and in my version goes right through the fuse first, and then these Y capacitors go to ground from the hot and neutral. So it goes hot, fuse, switch, and then back out through the neutral. And that's standard convention for wiring now. This is the 2 capacitors in the combo can, the 100 and the 20. I checked all these resistors, and they're absolutely perfect. I pulled a leg on this one because one of the legs was a little short anyway, and I was going to replace it, but it was literally 5,000 ohms. Like, I'm not going to replace that. It's absolutely perfect. So, and then, of course, what turned out to be pretty cool when I pulled the tubes is that these 3 are all Hallicrafter tubes. They're all labeled Hallicrafter. And so if I can get that in the picture there, I don't know if I can. If we can see it or not. A little hard to tell. But each one says Hallicrafters on it. So that's pretty neat. I love that. Let's put this capacitor on my capacitor leakage tester and see if it's leaking. So this is my Sprague Telemic T0-6 capacitor analyzer, and I have the electrolytic hooked up to the 100 microfarad terminals there. And what you do is you select the capacitance range, and of course the capacitance is low on this, so I'm not even on the correct scale. I had to go to the next scale up to get a reading, and you find the capacitance and open the window, and then you adjust the power factor at 60 cycles to get the maximum opening. And you kind of go back and forth, kind of like tuning an antenna tuner, until you find the maximum opening, and then take the reading here. Now, this is reading about 20, 30, around 40 microfarad. And you remember from the BK Precision reader, it was closer to 25 microfarad. Well, the BK Precision, the closest I can get to 60 cycles is 100 cycles, and which is, you know, closer to 120. I'd really like to use 60 and 120 because that's where power supplies live. But at least I know this one's 60, so it's still way low, though. You can see this is wide open at right around 40 microfarad. So let me get this set up for leakage. The cool thing about this leakage tester over my Heathkit leakage tester, which is a great instrument, I use them both frequently, is that this one will actually show you the exact amount of leakage, which is kind of handy. So let me get that set up. Before I show you the leakage test, one cool thing about this tester is that it actually tests the insulation resistance on paper, micas, and ceramics. And I mean, that's a pretty amazing feature. And maybe I'll do a full-length video going through this capacitor tester. But if you get a chance to grab one, and this one's fully restored, definitely do it. They don't go cheap, but they are awesome. Okay, this is such a great demonstration. I was getting readings so crazy testing this capacitor that I thought there was something wrong with my telemic. So I got out my Heathkit checker, which I know is also perfect. It's an IT28 to kind of verify the results I was seeing on the telemic. So what you do is you hook up turn it on, let it warm up, which it has. This should be in 60, the highest scale, voltage all the way down. You go to test. It's hooked up, and you have to, of course, watch polarity. Then it says press and read to hold the volts while you're setting. So I go to set 350 volts, and the thing is buzzing, and it's already way above where 300 volts normally is. And when you release, it shows the leakage. Look at that on this scale. That's 60 milliamps. We're at 20 milliamps of leakage, and I'm not even near the rated voltage. I thought, wow, that is crazy. Let me turn down the voltage and go to the 6 milliamp. And I'll just turn up the voltage until we get about 6 milliamps of leakage. And it is coming down a little bit. It says you can burn these things in for about 30 minutes on devices that haven't been used for very long. But I've been testing this thing for 15 minutes, and there's been really no change whatsoever except that little amount that you see there. Let me go to discharge and disconnect the capacitor. And look at this. All we were using is around 200 volts on a capacitor rated for 350. And we were getting huge amounts of leakage. They provide this chart here. We're in the 250 to 350 working volts. At 100 microfarad, the most you should see is 2.8 milliamps. We're seeing 20 milliamps at 100 volts less. I thought, man, there must be something wrong with this thing. Well, let's hook this up to the Heathkit. Let me adjust this just a little bit here. So we're in discharge, and we'll test the same one here. We're in electrolytic, and the voltage is all the way down. We're going to use the window there, and we'll start turning up the voltage. So we'll go to leakage, turning the voltage up until we see the window close. Okay, closed and opened so it can hold 50 volts. Here's 100 volts. Look at that. This is rated 350 volts. That's how much leakage there is. Now, I know to discard this capacitor, but this actually shows you how much the leakage is, which is kind of neat. So, I mean, I'll turn it up a little bit more, but I'm not going anywhere near the rated voltage. It won't even hold 100 volts. So this thing is a goner, and thankfully I'm replacing it. Let's check the other section. It's a multi-section can. This one is 20 microfarad at 300 volts. Let's see how this one does. 100, 150, a little bit better. 200, good. 250, okay. 300. Well, it is opening, but I wouldn't use this. I wouldn't use this capacitor in any of my devices with that kind of performance. All right, let's look at that section. Discharge. Let's look at that section on the telemic. So that is the 20 microfarad is the triangle one. See if I get this right here. Okay. So we're in on, turn the voltage down, 60. This one is in the 60 to 600 range. Let's go to test, and let's bring up the voltage. And again, this one is 300. See if we can get 300. Power supply is struggling to do it. It is current limited. There's 300 volts. Boy, look at the leakage. At 300 volts, it's 20 milliamps. That is a lot of leakage. So again, that capacitor is long past its, sorry about the view there. That capacitor is long past since its useful life. So anyway, and the manual says that don't go above 10 milliamps. So let's see what the voltage is there at a 10 milliamp setting. Look at, I had to crank this thing up to produce 500 volts to get it to show 300 volts. So this thing is a goner. Anyway, that's kind of a cool demo. I hope you like that. Okay, we're all complete on the top side. Everything's cleaned. The new capacitor looks awesome in there. Everything is back together on this side. On the bottom side, I buzzed out all the resistors. All these capacitors are all excellent quality, and they rarely fail. The electrical system is, or the supply side is all fixed up, and double checked all the wiring. I checked the resistance across the power cord. There's no shorts. Everything looks good. So I only found one resistor that was a little bit low, and it's R9 right here, or high rather. It was supposed to be 560 ohms, and it was indicating 800 ohms. So I replaced that one. All the other ones, even though I measured them in circuit, were super close. If you get one that's super high, it probably is high. Then you pull a leg and check it, and in fact, this one was super high, 300 ohms high, a pretty high percentage, almost double. So let's see. I think on the underside, we're all ready to go too. So I'll put the bottom on, and then we'll get set up for a smoke test and calibration. Okay, I think we're ready for a smoke test. All of the connections have been checked, and I've got it hooked up to one of my DIY Variacs. This one has a Hobbs meter for burning in projects, separate ammeter and voltmeter, which is super handy. and it is fuse protected, but I'm going to watch the ammeter closely as I bring up the Hallicrafters. So let's turn the line voltage on, and we'll start bringing it up, and we'll watch the ammeter for anything unexpected. I've got the Hallicrafters HA-5 in the 80 meter section. I do see the bulb, indicator bulb coming up, no unusual draw. Yeah, I think we're going to be good. And there's all the way to 122, so I think we're good. Let's go to Cal, make sure we don't see any changes. This brings the oscillator in. Yeah, we're okay. Everything's lit up. Starting to feel a little bit of heat on the tubes. I'd say we're good. I think we should go into an operational test. All right, here we go in the alignment section. Since we think this thing's safe to use, so you build this little load here, 5,600 ohms and 100 picofarad capacitor. This becomes essentially the dummy load. The impedance, the output is 5,600 ohms. So I'm going to use my SDR as a receiver because it's essentially a pretty good spectrum analyzer. I don't know why that was so hard to come up with, but it's essentially a great spectrum analyzer because we need 5 megacycles and 5.5 megacycles. And I have a little small non-metallic screwdriver. We need an alignment tool for the slugs. I'll have to grab one of those out of the tools. RF voltmeter. I'm going to use the Hewlett-Packard 3400B. Which is good to, I think, 20 megahertz. So that should be plenty. We only need 5 megahertz. And let's see, and there's the dummy load. So we have everything we need. So we're going to remove it from the cabinet. It already is. We're going to insert the test load. We're going to set the receiver to 5 megahertz. They called it megacycles back then. Calibrate the receiver. We don't need to do that. It already is. Set the VFO to the cal position, and then align the frequency dial with the capacitor fully meshed. That's already been done. Whoever built this thing at the factory did that. Then we'll turn the unit on. We'll set the tuning dial at 53 megacycles, which is just off of fully meshed. Which is nice because it gives you a little bit of room, and adjust the oscillator coil L1 to 0 beat with 5 megacycles. And then you slip to the other end and go to 50 megacycles with the receiver at 5.5 megacycles. And then you adjust capacitor C2, which is actually a screw, which is kind of interesting capacitor. And then you kind of go back and forth until you've got the two ends of the bands lined up, and then you've calibrated the dial correctly. And then we'll move on to the mixer alignment. There's 3. And that's a pretty quick deal too. We'll show you that in a second. I guess while I'm here, this is kind of interesting, and I'll show you on the VFO in just a second when I move the camera. But when you're doing the mixer alignment, you're going to be going to L2A and L2B. So there's only one inductor in there, but there's 2 sections, and they're both accessed from the top. So L2A and L2B, one is below the other inside the same tube. Let me show you that. Okay, here's the load. We're going to put in the 80 and 10 meter output here, and here are the inductors. Let me just make sure I'm giving you these correct. L2, L3, and L4 for the various bands. And there's a top section and a lower section. You kind of see that there's two sections there. Maybe it's a little easier to notice here and in there, but and then the setting the dial, we're going to use that inductor, and that screw down in there is actually the capacitor C2. So that's how we'll calibrate the two ends of the dial. So let me get that set up. So there's the mark under there. I'll move this so you can see it, that you set the dial to when the main tuning capacitor is fully meshed. And then you come up to 53 megahertz. And let me expand out so you can see the SDR. Okay, hopefully you can see all that. Here's the antenna lead from my SDR, and I just stuck an alligator clip in the core there. It's very loosely coupled. In fact, I think there's even signal without it. There is, but it's pretty weak. But, we're only in close proximity to this thing, and we're getting a great signal there. And you can see it's not quite lined up with 5 megahertz. So you set 53 megahertz here on the scale, and you calibrate for 5 megahertz on the SDR, and that's using where is it? L1. Okay, so let me turn that. Kind of show you where that is. There it is right there with the insulated screwdriver. It's just set up here again. Okay, let's bring that in. What, the other way? I'd call that uber close. Okay, let me turn the volume down. Okay, and then it says go to the other end of the dial and go to 5.5 megahertz on the SDR. Takes a while to get there. It's all the way at the far end of the capacitor travel. This tuning knob is so beautiful. It feels like it's a weighted knob. Just really well designed. VFO. All right. And there, if I can get it lined up, there might be a little parallax for you, but that's as close as I can get to 50. And boy, we are darn close there. Hopefully you can see that. There's a little screw down in here. I'll show you that one too. If you can see it, it's right there. That screw is the capacitor that we're going to be adjusting for this end of the dial. And let's see. Yep, that's bringing it in. And that is centered. Oh, a little too far. There we go. Okay. I'm actually looking right here because there's a little blow up of the scale, or you can look here. All right. Then it says go back to the other side. So we'll go to the other end of the spectrum, reset the SDR to 5 megahertz again, and we'll double check it again. I'll probably end up doing this about 5 times just to get it right, but I'll do that off camera. 53. I mean, it is so close. I don't think it really matters, but I'll bring it in just a little bit. Yeah, I'm gonna call that good. That is darn good. Okay, let's move on to the next step. Okay, now where's the fun in using a modern HP 3400B RF voltmeter makes far more sense to use an era-specific machine that is actually far more capable. This is my fully restored HP Model 410B. It is essentially a Sentinel ME26DU, which I also restore, and I have a nice one above me here that I keep around the shack. And this 410B is just absolutely beautiful. Here's the AC probe. It's also good to 700 megahertz like the Sentinel ME26DU. I've also got a capacity divider, which allows you to increase the range of the switch here by a factor of 100 to 1. And check this out, a 50 ohm line probe. So you pull the tip off here and insert this, and you put this in line with your devices, and you can actually use this to tune an antenna, or the find the resonance on the output of a signal generator, for instance. Really, really cool. And this thing, look at that. It's brilliant. Look at, beautiful. Anyway, so we're going to use this this bad boy. I just zeroed the meter. Did I? A little bit of parallax here. Yeah. Okay, the meter's zeroed. We're on the 100-volt scale. Let me get this thing hooked up in the back. And here's our tool to peak the inductor. So let's see. We're going across the load here in the back. So the positive to the output, and the other side of the 56 ohm resistor is the negative. And there's our output there. We're on the 100-volt range. And so it's like 30 volts. It should max this out almost. Look at that. Really strong output. That 6AQ5 amplifier is awesome. Anyway, so, all right, we're all set up. We're going to set 3.8 megahertz on the 80 meter scale here. And then it says set the VFO dial to 3.8 megacycles and peak L2A and L2B for maximum output voltage developed across the load. All right, so let me just confirm I'm going to the right one. L2 is the one closest to the outside. That's right here. Let me tip this up so you can see it, if I can do it without getting electrocuted. That's this one right here. Okay. Remember, there's two slugs in there. I'll do the upper slug first. That's going down. That's going up. Getting a little tight. I don't want to do it. It's going down, down. Okay, that's peaked. And that one's about the end of its travel, but the output is extremely strong, so I'm pretty, yeah, look at that. It's even off the 30-volt scale. So I think we're doing pretty good there. I'm going to call that a success. Let me just check the lower one again. Yeah. Yeah, we're peaked. Okay, that's great. All right. Then it says set the band selector switch to the 10 meter position. There we go. Set the VFO dial to 29.2 megahertz. It really is actually 29.2. And then go to L3A and B for maximum output voltage across the load. So L3 is the one in the middle. And again, I think I'll do the top one first. I'm not getting a change there. Check the bottom one. Oh, there we go. All right, that's peaked. And there's peak there. Let me just check the bottom one again. All right, outstanding. All right, that one's peaked. And then insert the output test load into the 6 and 2 meter output jack. Remember, there's a separate one for each of those. Let me pause the video while I do that. Okay, that was easier than I thought. Okay, and then band selector to 6 meters. There it is. I don't have the 2 meter crystals, so I won't be able to do that one anyway. But set the VFO dial to 50.25. So 50.25. I think that's way down here. 50.25. There's 50. Let me find 50 and a half. That was 50 and a half there, I think. So there's 1, 2, 25. Let me just make sure I'm doing this right. $90, $80, $70, $60, $50. No, they must be in fives. 10, 15, 20, 25, 30, 40, 45, 50. Yeah, that's definitely. And then 1, 2, 3, 4, 5. Okay, right there. And then go to L4A and L4B. That's the one closest to the inside. And I'll do the top one first. Yeah, got a little bit more output there. Nice. Ooh, okay. Just a hair off over the ears. Plus I changed a few components, so that's understandable. But all right, we're peaked. Okay, well, here's the test setup and the whole reason you should own a Hallicrafters HA-5 VFO, and that is the model HT-40 transmitter. So it's a bit interesting how you hook this thing up, because you want the key to key both the transmitter and the VFO. So you end up not using the key jack on front, but 2 terminals on the back for that purpose. It can be remotely keyed, for instance, if you're using an SX140 receiver, which I have. It's right up there, and once it's restored, we'll put the 3 here on the air together. But for now, we're keying the VFO and the transmitter when in CW using the key and parallel connections here. It's safe to do both, so it's a little bit odd, but if you look at the manual here, the key jack, if this relay were closed, would be keying the transmitter and keying the VFO. So that made me a little nervous, but looks like that's the way it's done. Fix the camera a little bit here. Anyway, so we're in standby. We'll go to tune, and we'll turn Cal on. I got to turn the mute off on the SDR, and we'll put ourselves right on 14.114. The VFO's been on for about 15 or 20 minutes, and it is drifting up a little bit. I think that'll eventually settle in and not drift at all. But keying is not pulling the VFO, which is nice. So then we'll go to standby. We'll go to CW and grid current, and we'll peak the drive. There we go. Good drive. We'll go to RF output, and I'm going to mute here, otherwise we're going to be blasting in there. And so now the cal is off because in CW, the key will key both. Okay, and we'll peak the RF output. That looks good. Showing about 42 watts. I'll show you. Yeah, it's pretty decent. And the same on the MFJ tuner that it's on, if you can see that, hopefully. Anyway, Get you set back up here. Set my call sign. And should we see if we can get some hits on the reverse beacon network? Let's give it a whirl. Give it a second. I found that when the note gets pulled, it's hard to get recognized by the reverse beacon network. What I mean by that is this. I think go back to Cal again. Yeah, we're basically on frequency. And we're in CW. Let's let you hear the note. Can you hear it pulling a little bit? Just chirps a little bit. So that might make it difficult for the reverse beacon network to give us a response. Let's try one more time. You can see the SDR auto mutes during transmit, which is pretty handy. I'm on an MFJ-RF switch that enables that antenna changeover portion anyway, using RF, and then the software itself does the muting. So, oh, look at that. We got some hits. Let's see. The farthest one is 588 miles at 12 dB. Not bad. 322 miles at 27 dB and 150 miles at 28 dB. Don't forget it's daytime and we're on 40 meters. But I would call this restoration a success. I'll put it to the test in other bands and report on a future video. Anyway, thanks for joining me with this extra long video. Hopefully you got something out of it and you got to see some cool vintage tools put to use. Smash the like and subscribe, and hopefully I'll have some more content out here for you shortly. Thanks again. This is W3KW.